Welcome to EDU World Space.
We are given a function f, we're given its graph, and we're told that g of x is the function which is the integral from 0 to x of f of t dt. In part A, we're asked to evaluate the function g for values of x between 0 and 6. Well, as g of x is defined, it's the area between the graph of f and the t-axis, with the areas below the axis being negative, and therefore, looking at the graph of f, well, first of all, g of 0 by definition is the integral from 0 to 0 of f of t dt, and since the limits on the integral are the same, this is 0. G of 1 is the integral from 0 to 1 of f of t dt. Looking at the graph of f, well, the area under this part of the graph is 2 whole squares, and so this is simply 2. Likewise, g of 2 is the integral from 0 to 2 of f of t dt. Looking at the graph of f, we see that the integral from 0 to 1, which we saw was 4, plus the integral from 1 to 2, which is 0.5 times 2, for a total of 5. G of 3 is the integral from 0 to 3 of f of t. So this is g of 2, and by the additivity of integrals, g of 2 plus the integral from 2 to 3 of f of t dt. From previous parts, this is 5 plus, and the area of this triangle is 0.5 times 4, the height of the triangle, for a total of 7. Finally, g of 6 is the integral from 0 to 6 of f of t dt, which from previous parts this is g of 3 plus the integral from 3 to 6 of f of t, and this is 7. And then this area, well, this is below the x-axis, and so it's actually a negative area. So 7 minus, and this is a triangle and a square. So we have the area of the triangle is 0.5 times the height, which is 4, plus the area of the square, or rectangle I should say, which has a height of 2. Which comes out to 3. Then in part B, we're asked to estimate g of 7. Well, by additivity of integrals, this is the same as integral from 0 to 7 of f of t which is equal to the integral from 0 to 6 of f of t, plus the integral from 6 to 7 of f of t. Using part A, this is three plus, say, about 1, which is 4. Then in part C, we're asked where our function g has a maximum value and where it has a minimum value. Well, we see that from x equals 0 up to 3, the area is all positive. So, in fact, the cumulative area, g, is greatest, and therefore has a maximum value at x equals 3. Likewise, we see that from x equals 3 to 7, the area is negative. And so we see that our cumulative area g is least, or it has a minimum, at x equals 7. Finally, in part D, we're asked to sketch a rough graph of the function g. Now, before we do this, notice that from part A, we saw that g was in fact always increasing from 0 up to 3. And then when x equals 3, the function was at its maximum. And then in the interval from 3 to 6, the function was decreasing. And so the graph of g starts out at 0, reaches a maximum at x equals 3, and then decreases again. And it looks something like this.